Good morning. This is question number 10 from homework number 2, Stats 243B. You want to obtain an estimate of a population mean from incoming fall transfer students based on previous population. Standard deviation is approximately 6.9. You would like a 90% confidence interval that you estimate to be within 2 of the true population mean. How large do you need your sample size to be? Okay, so the first thing we're going to do is remember that when we build a confidence interval, it's this formula, plus or minus our z critical value, because we're for means and we have population standard deviation, times the standard deviation divided by the square root of n. Right? This is your margin of error. You want that margin of error to equal 2. So now we have this 2 equals our z critical value times our standard deviation, which we know to be 6.9, divided by the square root of n, which is what we are looking for. So our first question becomes, how do we find the z critical value for a 90% confidence interval? We're going to use some technology for this. We're going to go to our TI-89 or to our Minitab and figure out what that z critical value is. To do that, we're going to go to, so on your TI-89 or your calculator, you're going to go into the distribution button, second distribution, go to inverse normal. You can choose center on the newer 83s in terms of tail, but on the older ones, it just does the left tail, so you would put 0.05. If you choose center on the newer ones, you put 90, because you're taking the 90% of the area in the center, where it says area. You're doing 0.05 because, so if you think about this, what's going on is you have 90% of the area in the center. You have 0.05 down here, 0.05 down here, up here. So if you do right, you would do 0.95, because you'd have 95% to that point. If you do left, you do 0.05, and if you do center, you do 90. And that gives you the z critical value of 1.6448. And so now I would just need to solve for the square root of n. So 1.6448 times 0.69 multiply both sides by the square root of n. You can just do a little bit of algebra 1 here. Divide both sides by 2. And then to get n by itself, square both sides. So the sample size I would need is 32.2. You can't take 0.2 a person, so you round up to 33. And your answer there would be 33. Now there is a formula, like if I were to just do this, right? Your margin of error is equal to your z critical value times your standard deviation divided by the square root of n. If I were to just do this and solve for n naturally, the formula would be n equals z times the standard deviation divided by the margin of error, that whole thing squared. So if you want to just plug it into that formula right away, you'd get n equals 1.6448 times 6.9 divided by 2 squared, and then you'd get this up here as well. All right, let's take the other one that we had a question about. Okay, this is the same idea. It says you are a researcher, lifelong span of bacteria, primary sample of 40 bacteria reveals a mean of 80 hours with standard deviation of 6.4. You would like to estimate the mean lifespan of this species within a range of 0.6 hours at 95% confidence. What sample size would you need to get a margin of error to this. Now, I just told you that formula is equal to n equals z alpha standard deviation divided by your margin of error squared, right? So if I'm going to work from there, I'm going to take the standard deviation that I have. So n equals z times 6.4 divided by 0.6 squared. Now I need to figure out what my z is for 95%. If I did this on Minitab, I would go to inverse. I would go in the calc menu down to distribution, choose inverse, choose normal, mean of 0, standard deviation of 1, and put my area. Just think about this. Area is at 95%. That means I have 2.5% on each side here. So I put my area at 0.025. I'm going to do it on the calculator. Again, I go to my distribution tab, go inverse normal, area 0.025, 0, 1, tail left, hit paste. And it's going to give me a negative number, of course, but we're going to use the positive version of that. Really doesn't matter if you use the negative version because you are squaring it. So it's going to be fine either way. So you times that by, so we take n equals 1.95996 times 6.4 divided by 0.6. That whole thing squared. So answer times 6.4 divided by 0.6. That is negative 20. We're squaring that, so it's going to be positive. And we get 437.07. We round that up to 438. Even though this is such a small number, we always round up because if there's any decimal at all, because you can't have 0.07 of a person, and you want to guarantee that you have the correct margin of error. So you take one more than what you thought. Hope this is a helpful video. Let me know if you have other questions.